So this was the last part. We were discussing about how to distinguish lactic acid from acrylic acid. Lactic acid does not contain a carbon-carbon double bond. Acrylic contain. So we can add a bromine, no change, and here it will decolorize. The next one, describe a test other than using an indicator which shows that both contain chem which shows that both chemicals contain acid group. How we can show that they are acids? So what we can do, we can add carbonate and it will fizz. Other than using an indicator. So you cannot mention methyl orange because it's use this statement other than indicator. So if other than indicator you want to show the substance is acid, so add a metal carbonate or add carbonate. And acid, if there is acid, it will give fizz or bubbles or effervescence. Hydrolysis is used in chemistry to break down complex molecule into simpler one. The compound C double bonded with O or CO are esters. Give the name and the formula of two compound when the ester ethyl propanoate is hydrolyzed. So what are the esters formed? Sorry, what are the compounds which will form this ester ethyl propanoate? So first name is from the first name of ester is from alcohol and the second name is from acid. So it will be ethanol and the second name is from acid, so propanoic. And formula of this compound, so how to give the formula of these compounds? Ethanol is C2H5OH and propanoic acid is C3H5COOH. Because C2H5, 2 carbon and plus 1 carbon of acid group, that's why it's propanoic acid and ethanol. Okay. Fats are naturally occurring esters, natural condensation polymers. They can be hydrolyzed by boiling with sodium hydroxide. So when we hydrolyze the fat, actually what it will form, when we hydrolyze fat, it will produce glycerol and fatty acid. And the fatty acid react with sodium hydroxide, which will produce a compound we call soap. What type of compound has a formula C17H35CONA? And what is the main use? So what is the type of the compound? What is this type of the compound? When C double bonded with O or COO is there. So it is a salt because when acid react with an alkali, what it result? It's an ionic compound, or you can mention it is a salt. Because when acid react with an alkali, this result in a formation of a salt, and that salt is called soap. And the next part, what are the uses? So for cleaning or detergent, Yeah, you can mention soap in washing hand as well. Then name a synthetic polyester. Synthetic polyester means man-made polyester. What is the name of man-made polyester? So that's terylene. That's a man-made polyester. The structure of a typical protein, they give you the structure of the protein. What is the name for polymer linkage? What we call this bond or a linkage? Peptide or amide? Then draw the structure formula of man-made polymer with same linkage. So man-made polymer with same linkage means you have to draw nylon here. So for a nylon, how to draw the monomer are dicarboxylic acid react with diamine. So C double bonded with O. We just have to draw the polymer. Carboxylic acid will lose their OH and amine will lose their H. And continuation of the structure and put a bracket in. The next part is related to the separation technique. We already completed that topic, so we'll discuss. Protein can be hydrolyzed to a mixture of amino acid which are colorless. Individual amino acid can be identified by chromatography. The RF value of the amino acid glycine is 0.5. Describe how would you show that was present in the chromatogram. So basically what you have to do, you have to explain how you will work out. So what we will use a chromatography, but amino acids are colorless. So when we use a chromatography, place the sample of on origin, drawn with pencil, then use suitable solvent. Because amino acids are colorless, so you have to add another term, that you have to use a locating agent, spray the chromatogram, with locating agent, then measure distance moved by solvent front and spot. Then the formula for a RF value, so the RF value is equals to distance moved by the spot divided by distance moved by solvent front. And that is measured from the origin. So this is how we carry out a simple experiment to know the type of amino acid present in the mixture. Okay, in the next question, the structural formula for butanol is given below. This is a structural formula of butanol. Butanol can be made from petroleum and also by fermentation. Describe the chemistry of making butanol from petroleum by the following route. Like we have a petroleum, then we want to make butene, and then we want to make butanol. So first for a petroleum, what we will do for petroleum? Which process we will use for petroleum? Petroleum is a mix, means the crude oil, which is a mixture of hydrocarbons. So first we will do a fractional distillation of a petroleum. So fraction distillation of the petroleum, we will have different fractions. Then how to get a butene from the fractions which you obtain from crude oil or petroleum. So we will use a cracking of a long chain hydrocarbon. So cracking of long chain fractions produce alkenes such as butene. Then last, from butene, how we'll convert butene into alcohol? So add steam to the butene that is by hydration. And the process is called hydration. So this will result in a formation of, or the hydration of the butene result in a formation of butanol. Explain in general terms what is meant by fermentation. And it's of 3 marks. So you have to explain the meaning of this fermentation. Anaerobic respiration by the yeast to release alcohol or produce alcohol and carbon dioxide. Or glucose or sugar change into alcohol in the presence of yeast, which is having enzymes acting as a catalyst. So yeast is having enzymes which act as a catalyst. And you can write an equation as well. That's the 3rd mark, is for writing the equation. The next part, is butanol can be oxidized to carboxylic acid by heating with acidified potassium manganate 7. Give the name and structure of the carboxylic acid form. So oxidation of alcohol produce carboxylic. If it is butanol, which carboxylic acid will be there? So that will be butanoic acid. And for butanoic acid, but means 4 carbon. So you will draw 4 carbon. And carboxylic acid, so C double bonded with O, ONH. This will have two hydrogens, two hydrogen, and three hydrogen. Then the next question, butanol, butanol react with ethanoic acid to form a liquid X. So butanol reacted with ethanoic acid, which has a sweet smell of bananas. Its empirical formula is C3H6O and its relative molecular mass is 116. What type of compound is liquid X? So because butanol react with ethanoic acid to form liquid X, so basically this type of compound, that is ester. Then give a molecular formula. How to give a molecular formula? As you can see, you can draw the structure. There's also another way to find a molecular formula from empirical formula that we will do in the last chapter, which we are left with stoichiometry. And you have to draw the structure when butanol react with ethanoic acid. So the structure of the alcohol, it will form butyl ethanoate. So butyl ethanoate, we have to draw the structure of butyl ethanoate. So but means 4 carbon. First for ester, so C double bonded with O and O. So but means 4 carbon, so 1, 2, 3, 4. And eth means 2, 1 is already there, so this is a second. Then we just have to draw the hydrogen because already one bond is formed, so this will have 3 hydrogen. Two bonds are formed, so this will have 2 hydrogen. This will also have 2 hydrogen, 2 hydrogens, and 3 hydrogen. So what is the molecular formula? Molecular formula, from structure you can count the number of the carbon, hydrogen and oxygen atom. 1, 2, 3, 4, 5, 6 carbon atoms are there. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen are there, and 2 oxygen are there. That's why the empirical formula is C3. When we divide C3H6, O will be there, the empirical formula. Butane is an alkene. It has the following structure. The equation for a complete combustion is given. Insert the missing volume, that is related to stoichiometry. Butane react with chlorine to form two isomers of chlorobutane. What type of reaction is this? When alkane react with halogen, so we call that as a substitution reaction. And isomers, the term isomer means they have the same molecular formula but different structures. So when two compounds have the same molecular formula but different structure, we call that as isomer. Draw the structural formula of the two chlorobutanes, means the two isomers. When butane react with chlorine, what will happen? One of the hydrogen will be replaced by chlorine. If the first hydrogen is replaced by chlorine, then it will be 1 chlorobutane. But if the second hydrogen is replaced by chlorine, so it will be 2 chlorobutane. So we just have to draw the two isomers of chlorobutane. But means 4 carbon and chloro here means chlorine is attached. If chlorine is attached to the first carbon, this will have 2 hydrogens, 2 hydrogen, two hydrogens and three hydrogens. So one chlorobutane and two chlorobutane are the two possible structures. One of the chlorobutanes reacted with sodium hydroxide to form a butanol. Butanol is oxidized to carboxylic acid. State a reagent other than oxygen which will oxidize this carboxylic alcohol to carboxylic acid. So what we need acidified potassium manganate 7. Potassium dichromate 6 can be used, but the actual for practically potassium manganate 7 is used, which is a better oxidizing agent for this reaction. So acidified potassium manganate 7, and name the carboxylic acid formed. So if butanol is oxidized, it will produce. So this will form butanoic acid. Butanol react with ethanoic acid to form an ester. Name this ester when butanol react with ethanoic acid. So this will result in a formation of butyl ethanoate. The first name is from alcohol and the second name is from carboxylic acid. And then you have to draw the structure to show all the bonds. So butyl ethanoate, so C double bonded with O, but means 4 carbon and eth means 2 carbon, one is already there, one we will draw, and remaining hydrogen you will draw accordingly, checking the number of the bonds which are used. Petroleum contain hydrocarbon which are separated by fractional distillation. Complete the following definition of hydrocarbon. A hydrocarbon is a compound which contain carbon and hydrogen only. What is meant by term fractional distillation? So separating the mixture on the basis of the boiling point, we call that as fractional distillation. A separation technique which is used to separate two or more miscible substances on the basis of their boiling point. Some of the fractions obtained from petroleum are given below: bitumen, lubricating fraction, paraffin fraction, gasoline. Bitumen, what are What you have to just mention one use. What is the use of bitumen? Making roads, road carpeting, roofs as well. That's correct. So bitumen is for making roads, roof, even for waterproofing. That's why when they are making the structure for the house or any building, they cover this with a bitumen so that it will not soak up the or absorb the water. Then lubricating fraction. What are the uses of lubricating fraction? It is used to reduce the friction. That's right. It is used for waxes, Vaseline, grease, reduce the friction in the machine. This lubricate, like even in the car engine, we are using a lubricating fraction which reduce the friction between the parts inside the engine. Paraffin fraction. What are the uses of paraffin or kerosene? Paraffin fraction, it is used for jet fuel as well. It is used for stoves, and gasoline is there. Gasoline or petrol. Fuel for cars, vans, trucks. Petrol for vehicle. That's right. The structural formula of a cyclohexane is drawn. The name gives the information about the structure of a compound. Hex because there are 6 carbon atoms, and cyclo because they are joined in a ring. What information about the structure of this compound given by ending a name ANE? So ANE means they contain, it's of 2 marks. So you have to mention the answer. When you are mentioning the answer, you will mention it is alkane or a saturated hydrocarbon which is having carbon-carbon single bond. So 1 mark is for mentioning it's a hydrocarbon, because hydrocarbon can be alkane, alkene, or alkyne. So 1 mark is for mentioning hydrocarbon, and the second mark is for mentioning that it has a carbon-carbon single bond. Molecular, what are the molecular and empirical formula of cyclohexane? Molecular formula means actual number of atoms. So how many carbon atoms are there and how many hydrogen atoms are there? So C6 in H12. And what about empirical formula, the simplest ratio? So simplest ratio is 1 is to 2, so CH2. Draw the structure formula of cyclobutane. So cyclobutane, but means 4 carbon in a ring, a loop, and then each contain 2 hydrogen. So that is cyclobutane. Deduce the molecular formula of hexene. What is the molecular formula of hexene? Because it's an alkene, so the number of the hydrogen are twice as compared to number of the carbon. So C6 and H12. You can also use the concept of a general formula CnH2n. So number of the hydrogen are twice as compared to number of carbon. Why cyclohexane and hexene are isomers? You can see molecular formula of hexene is C6H12 and molecular formula of cyclohexane is C6H12 because they have the same molecular formula and different structures. That's why we call them as isomer. So you have to write the definition of isomer here. Describe a test which could use to distinguish between cyclohexane and unsaturated hexene. So how we can test? So we can add a bromine, aqueous bromine you can mention, or add bromine with cyclohexane, no change, no visible change, and it will decolorize. A polymer can be made by polymerization of a simple molecule such as monomer. The structure formula of polymer is given. This polymer is made by addition polymerization. Draw the structural formula of monomer. So if you want to draw the monomer, just take two carbon atoms of the structure, draw as it is, and the only difference, because a monomer contain a carbon-carbon double bond, so there should be C double bonded with C. Then two monomers shown below form a nylon, which is a condensation polymer. Draw the structure to show one repeat unit of polymer which is formed. So what happened? Because diamine react with dicarboxylic acid. So one side you will, for carboxylic, lose their OH and amine will lose one of its H. So when we draw the structure, we have to show amide or a peptide linkage. So for amide, we remove H from one side, then this box. And for carboxylic acid, we remove OH, so C double bonded with O is left. This shaded part, and then C double bonded with O. That is a one repeat unit. If two repeat unit, I will draw the same structure by repetition. Name the natural molecule which contains same linkage as nylon or polyamide. So natural molecule is protein. And differences between addition and condensation polymerization. Addition polymerization, only one product is there. Condensation polymerization, a polymer and a small molecule such as water is also given off. In addition polymerization, identical molecules are there unsaturated, where in condensation, it can be identical, it can be different. Many polymers are non-biodegradable. What is meant by a term non-biodegradable? The term non-biodegradable means the polymer does not decompose by itself. We call that as, or not decomposed by bacteria, cannot easily or cannot be decomposed by bacteria. We call that as non-biodegradable. State 3 problem caused by disposal of non-biodegradable polymers. Like when we dispose of these non-biodegradable polymers, what are the problems caused by these? So it will cause a visual pollution, or it will we will be a shortage of the landfill sites, because if we are dumping and the polymers dumping this waste, a polymer is not decomposing, and if it is burned it will release the toxic gases. It will be danger to the wildlife, animals, even for marine or including sea. A danger of a wildlife feeding on these materials. Then storage tank of for cold water are now made from polymer because they are cheaper than metal tanks. Suggest two other advantage of making a cold water tank from polymers. Like the water storage tank, you will find they are made up of fiber, polyester, polymers. So what are the advantage other than it is cheap? It is a good insulator. So it is a good insulator. It keeps the water at normal temperature, like it does not heat up or does not make the water warm. It is easy to manufacture or mold as well, and it resists corrosion, unreactive, does not rust, and it is having a low density. So these are some uses or advantages of making these water tanks made from polymers. So these are the questions. We completed organic chemistry. That's why I discuss this whole session for keep this whole session for organic chemistry. Next week we'll start our last topic of syllabus, which is stoichiometry. Stoichiometry is based on the calculation. So with stoichiometry we will start the revision as well from the past paper, and do exam questions, past paper questions on a regular basis. Any question related to the class today? Okay, so I'll end the session and share this.